So let's look at how we can determine the number of significant figures a number has when written in scientific notation. So if we have a number like 6.022 times 10 to the 23, the rule basically goes something like this. The times 10 to the 23 is the part that controls the movement of the decimal place, but doesn't affect the precision of the number. All we have to do is look at this front part here, sometimes called the mantissa, and count the number of significant figures. Once we have the number of significant figures here, then it's the number of significant figures for the entire number. So 6.022, so again the rules are any digit that is not a zero counts. Zeros count if they are captive, like in this case. However, if they were here in a leading position, they would not count. And if they were to the end of the number, then they would be counted as long as the number had a decimal place. So this makes this 4 significant figures. Okay, so if we look at a number like, let's have a look at a number like 1200, let's say. 1200 has 2 significant figures as written, the reason being that the 1 and the 2 are non-zero digits, and the zeros to the end are. If we wrote a number like 1200 period, then at this point here, the 1 and the 2 would be significant. The zeros at the end, because there's a decimal point of the number, are counted, so this has 4 significant figures. Okay, so now what happens if we wanted to write a number like 1200 to 3 significant figures? Now you might be looking at this and saying, well, they're all just 1200, right? So what's the point? Well, when we write 1200 like so, what we're really doing is we're saying that last significant figure has some error, and it's plus or minus 1 by convention. So this means that the real measurement's between 1100 and 1300. When we write it like so, then we're saying the error is in this 4th digit here. So the real number is between 1199 and 1201. And if we were to write this to 3 significant figures, we would be saying that the error would be in this underlined digit here. So it would be somewhere between 1190 and 1210. And this is where scientific notation actually makes it quite easy to write. So in scientific notation, we can take the decimal point and we can move it so that it produces a number between 1 and 10. So that would be 1.2 times 10 to the 3, because we moved it 3 times. Now that has 2 significant figures as written, because the 1 and the 2 are significant. Now if we needed a 3rd significant figure, what we would do is we would just put a 0 at the end. So 1.20 times 10 to the 3. So that now has 3 significant figures. Remember, zeros to the end of a number are significant if there's a decimal point in the number. And again, if we wanted to have it to 4 significant figures, we could write it as 1.200 times 10 to the 3. And if we wanted to have even more significant figures, we could just keep adding zeros to the end. So significant figures and scientific notation go hand in hand, and scientific notation is a very nice way to write a number that otherwise in regular decimal notation would be difficult to show the correct precision.